Okay, good evening, everybody. So this is our first flipped classroom of the year, and so what I'm going to do here is I'm going to give you the notes, and you should be copying down what I'm doing. But in addition to that, you should be writing down some of the things that I'm saying so that the notes will make sense. If you don't write down some of the stuff that I'm saying, then the notes can get kind of jumbled, and you won't be able to follow along later. So, all right, we're going to start off talking about multiplication today. And so multiplying using alternative algorithms. We've talked a little bit about this in the past. We're going to go much more in depth today. So we're going to start off kind of way back at the beginning. When you have the problem here, 3 times 4, what that typically means is 3 groups of 4. And so if I want to demonstrate that, I could say, okay, there's a group, there's a group, and there's a group, and then what's inside is 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so that would be a typical way of showing that we have 3 groups of 4. Another way we could show it would look like this. We could have 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. If we're looking at this second way, what this kind of reminds us of is the base 10 blocks, and each one of those being units. And then we could take a look at the how many we have. Does it make a long? Does it make a flat? You know, what do we end up with? So we can start showing students that each one of these is a group, and what's inside each group is 4 units, because that's what we had there. So if we take that idea and we look at this next problem, which is 3 times 14, and we have this idea of the base 10 blocks, then what we would have is we would have 1 long and then 4 units. And that would be one group. And then we'd have a second group that's the same as that, a long and 4 units. And again, this is of course in base 10. We're not talking about multiplying in other bases right now. So this is in base 10. So that would be an example of 3 groups of 14. So I have this group here, this one here, and this one here. And again, you know, we could count them up, talk again with students about how many of these are going to make up another long, and come up with a solution there. But we could relate this back to base 10, and we should relate it back to base 10 blocks. Okay, let's take a look at the next slide. Okay, the next slide, what we're going to do is we're going to multiply this, taking a look at their expanded form. We worked with the expanded form earlier in the year. So 26 times 32 can be written as 20 plus 6 times 30 plus 2. So if I'm going to multiply this in expanded form, what I just got to make sure that I do is that I multiply each one of these parts or terms by the other in the other number. So that means I'm going to multiply this times that one. So 20 times 30 gives me 600. And then I'm going to multiply these two together. And 30 times 6 gives me 180. And then I'm going to multiply 2 times that one, which gives me 40. And then 2 times 6, which is 12. And if I add those all together, that's 2, 12, 13, 834. And one nice thing about this is when you write this in expanded form, you're keeping the place value. So we're keeping track of the fact that this number represents 20, not a 2. And this represents 30, 30, not a 3. So by multiplying it out like this, we see that it has some better place value. Now, the problem with this is once they start to get much bigger than a 2-digit number, it gets a little bit cumbersome. So I'm going to kind of just do that. Apologize for that. So this would be 200 plus 40 plus 8 and 300 plus 10 plus 6. So you can see it's going to be a little bit more difficult to do. We can do it though. What is nice about this is this helps, we can start talking about multiplying powers of 10, what happens with these zeros at the end, so the kids can start to get pretty good at that. So this would be 6 and then 4 zeros. That's this one. And then that one is, whoops, I won't do that. Let me clear that off of there. And then I have 300 times 40, so that's 12, and then 3 zeros. And then I have 300 times 80, so that is 24. And then I can do the same thing with the 10, so 3 times 200, that's going to be 3 zeros and a 2. 10 times 40, 2 zeros and a 4, and 10 times 8, which is 80. And the last one I'm going to do over here on the side, I'm sure you can see how it's working. 6 times 200 is 1200. 6 times 4 is 240. And then 6 times 8 is 48. And then you add all those together and you would get your answer. So it works, and it does keep the place value involved, but it does get a little bit cumbersome. But it might help some students who are struggling and not understanding how the carrying thing works. This keeps it, as place value goes, a little bit better. Also, I like that it reinforces how to multiply powers of 10 so that the kids can get better at that. Okay, let's take a look at the next one there. Okay, area model. This happens to be my favorite, and the reason this is my favorite is because what I like to teach students as much as possible is I like to teach them a way to do a problem that works for the simple problems to the most complex, so that they don't have to learn something new every single time that they do something new. So the ways that I try and teach students is so that one method that I teach them can be expanded to the most difficult problems. If we teach kids how to multiply numbers like this, it's the exact same technique that they will use when they get into algebra when they have to start multiplying binomials. So I'm going to go ahead and show how this works, and then we'll talk about how it works with the binomials as well. So the first thing I'm going to do is I'm going to write down my number 46. Well, actually, let me change that. First thing I'm going to do is I'm going to draw a rectangle like this, because anytime you multiply two numbers together, you're finding the area of a rectangle. That's what that means, base times height. So now I'm going to write this just like we did in expanded form before. I'm going to write it 40 plus 6 like that. And then down the side, I'm going to write 30 plus 4. So I wrote the number 34 down the side, and I wrote the number 46 going across the top. And it doesn't matter which one you put where, I just decided to do it that way. Now what I'm going to do is I'm going to find the area of each one of these boxes. So to find the area of this box, I'm going to go base times height and fill it in there. To find the area of this box, I go base times height, fill it in there. This one is base times height, fill it in there, base times height, fill in there, and then I can combine my like terms. So 30 times 40 is 1200. 30 times 6 is 180. 4 times 40 is 160. And 4 times 6 is 24. And then they just need to add those up. If they're not quite capable of adding them up sitting inside the area like that, it's no big deal. They can write them like this: 1200 180, 160, and 24, 4, 16, 5, and 1. So 1,564. Okay, now you'd say, well, it seems like more work than if we just teach them traditional model. And I'm not saying it's not more work. It's a little bit more writing than if you teach them traditional model. But what I am saying is that when they get to more complex problems, they won't have to learn a whole new way of doing it. They will do the exact same thing that they did right here with a more complex problem. Okay, I'm going to quickly do this for the area model here. So first thing I do is I draw out a rectangle like this, and I have 200 plus 40 plus 3, and down the side I have 500 plus 20 plus 10, or excuse me, plus 1. And of course, what I like here most about this is that it's keeping the place values. I see the 500 and the 200. It keeps them for me. The thing I got to mention is where you draw the lines. I tell my students that anywhere there's an addition sign or a subtraction sign for later problems, that's where they draw a line. So anywhere there's an addition or subtraction sign is where a line goes. And that's true all the way up through algebra. Okay, so now 500 times 200 gives me 1, 2, 3, 4, 5 zeros. And then this is 1, 2, 3, 2. Oops, sorry, 4. One more zero in there. And then I have 1,500. And I have 4,860 and 243. And like we did before, if they can't add them in there, they could just start writing them up here, just like we did. Again, 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm not saying that this is the shortest way to do the problems, but I am saying that in the long term, this is the best because they don't have to learn anything new when they get to more complex problems. So I like to teach one way. It might be a little bit more work on the simple problems, but it's no more work on the complex, and to me that's a pretty good trade-off. And there we go, we'd add all those together, and that would give them their answer, whatever that adds up to. Okay, let's go ahead and take a look. That's called the area model. Let's go ahead and take a look at the next one for me. Okay, now we're going to take a look. All right, so let's suppose that you got students who are pretty good at this and they understand place value pretty well, so you're feeling like, let's just teach them the traditional model. And for a lot of kids, the traditional model works fine. I don't have a problem teaching it to students, but I don't teach it first. I teach it last, or at least towards the end. And then I'm going to show you another algorithm that if kids are a little bit struggling with the traditional model, it does the same thing, but it organizes them a little bit differently. So here again is the traditional model. Traditionally, what we would do is we would start right here, and we multiply those two together. And so 7 times 4 gives me 28, and we write an 8 down there, and we bring a 2 up. And again, that's not really a 2, it's a 20. These are the things I don't really love about this traditional model, is that kids lose the place value. But for a lot of kids, it's not a huge thing. Then you'd say 4 times 3, which is not really 4 times 3, but for our problem, it's 4 times 3 is 12, plus 2 is 14, so they get a 14 right there. And then I have seen teachers actually teach this. They actually tell students to put an X right here, which I'm not really sure why that is. It should be a 0 because this is now the number 20, and that's why it's a 0, because you're moving over a place value. So we put a 0 in there. 2 times 7 is 14. Bring a 1 up, which is not really a 1, it's a 10. 2 times 3 is 6, plus 1 is 7. And then the last thing that we would do is we would add those together. So we get 8. Oh, look at that, 888. I didn't know I did that, but I did. Okay, so that is the traditional model. I'm going to show you the same problem, except I'm going to use a different algorithm that is not better as far as like carrying the 1 and things like that. but it might be a little bit easier for kids to keep track of the numbers. We talked about some problems that my son Colby had that this might have helped and solved. Okay, so we have 37 times 24. Okay, so this one is called the lattice method. And so with lattice method, what you do is you go ahead and draw a rectangle like I did before, except we're not going to do the area model. We're going to do something a little bit different. So you're going to, across the top, you're going to write 37, and down the side you're going to write 24. And it does always have to go on the top and on the right hand side. So it has to go up here and here. You can't put the 37 on this side, and you can't put the 37 or 24 on this side. Okay, now once you have that, then you're going to go ahead and break it into boxes like we did before. Except the last thing we're going to do is we're going to cut this into lattice angles like this. Okay, now I'm going to multiply. And I multiply very similar to how I did up here when I just multiplied like this, just like this is 4 times 7 and 4 times 3, not 4 times 30. So I'm going to do the same type multiplication that I did in the traditional one. So here I have 2 times 7 there. And so what I'm going to do is I'm going to write that 14 in that box. So 1, 4, like that. Then I multiply 4 times 7, which is 28. 28, like that. Then I multiply 2 times 3, which is 6. So it's 0, 6. And then I multiply 4 times 3, which is 12, like that. What I don't love about this, you can probably guess already, is there's no connection to any of the place values whatsoever. It's just a trick or an algorithm to make it work. Then what you do is you add diagonally. So now I'm adding through these rows like this, and so I have 8 here, and I think someone in class mentioned you could actually extend these rows out like this, which is not a terrible idea. Kind of like that idea of extending them out. So then I have 8 there, and you have an 8 there, and you have an 8 there, and a 0. So your answer is 888, which we already knew. Okay, so that's lattice multiplication. It's just an alternative to doing the traditional one. The kind of things that makes it nice is that kids have a place to put these numbers, so it still looks like the number 28 or 14, where this does not really look like the number 28 with it being so far away. Okay, we're going to take a look at one last slide. This won't take too long. Okay, so the last way I'm going to show you is a way that is used in some areas of China, and it's another way of multiplying, and you'll see it's very, very different from what we've done so far. Not saying I like it, I'm just saying I'm exposing it to it. Okay, so the first thing we're going to do is we're going to write the first number, which is the number 15 here, and I write it like this. So I draw one line for the tens, and I draw 5 lines for the ones, like that. And then I'm going to do the same thing going the other direction for the 23. It's going to be 2 lines for the tens, and then 3 lines for the ones. Now, notice how I wrote these. I made a little gap in between here and a little gap here to separate so I could see what was what. And that's kind of important. Okay, so the top, this part right here, represents hundreds. And I see that I have 1, 2 intersection points, so that represents 200. These points here are tens. And so I see that I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I have 100 of those tens. This side over here is also tens, and I see that I have 10, 20, 30. So that is 30 tens. And then the bottom part here are my units, or my ones, and I count those up, and I see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have a total of 15 there. So then I can add 200 plus 100 plus 30 plus 15, and I get 345. And that's just another way of multiplying. So there's lots of different ways of multiplying. This is one method, and we've seen a couple of others. We will talk about the different types of algorithms that we've seen on Wednesday, and if you have any questions or I made mistakes, please make sure we get those cleared up on Wednesday. Okay, have a great rest of your weekend.